Hey guys, welcome. Yeah, so problem 3 here. And notice that this problem appeared both on the AB and BC 2018 FRQ. And in part A, we're asked to find f of -5 given that f of 1 is equal to 3. Now notice that the graph we're given here is the graph of G, which is f prime. So we're given the graph of f prime. So we're given a graph that tells us the slope of f. Now, knowing some information about f prime, we know how to go back to f. That is, from f prime, we know how to get information about f. We integrate, right? And so to find f of -5, first we'd want to write the integral from -5 to 1 of f prime of x dx. And that's because we know that this equals the difference between f of 1 and f of -5. And since we know f of 1 and we know how to interpret this as area, we're able to use this equation to solve for f of -5. Now, because we said f prime is g from what we're told, we know that we can write this equation here, as saying -5 to 1 of g of x dx, again, because g of x is f prime, and this is going to equal still f of 1 minus f of -5. Okay, cool. Now, what does this equal, right? That equals the area bounded by the graph of G, and then the vertical line x equals -5, and the other vertical line x equals 1, and the x-axis. Those are all the bounds. The two vertical lines I've drawn, the x-axis, and then the function G are the bounds. And so then we're looking for this area plus that area. Notice that this flat part contributes no area. And the area over here is the area of a trapezoid. And the area of the trapezoid is going to be, well, the average of the bases. So this base of the trapezoid, I guess I could have done that in a different color. But yeah, this base of the trapezoid is clearly of length 4. This base is of length 3. So the area here is going to be 3 plus 4 divided by 2, and then times the height, and the height we can use as this, and that's 3, right? So we've got this, so that's equal to 21, so that's 7 over 2 times 3, 21 over 2. But it's negative because it's below the x-axis, so this is negative, and I should put a negative right there also. This doesn't really look like a negative sign. I'll put it in red. So it's negative there and negative, right? Okay, cool. And then the area in this portion is just the area of that triangle, and that's clearly equal to 1, and it's positive 1. So let me use a blue arrow to stay consistent. So this is 1. Yeah? Okay, cool. So it looks like on the area from -5 to 1 of g of x dx is going to be the sum of negative 21 over 2, and then 1, which we can write as 2 over 2. And so this equals negative 19 over 2, right? And negative 19 over 2 is equal to, the right-hand side in this equation. And so the right-hand side will be f of 1, which we're told is 3, and then minus f of -5, and we're looking for f of -5. So we should see how to finish. The way we're going to finish is clearly we're going to next say that from this equation we have that f of -5 is equal to 3 plus 19 divided by 2. And 3 is 6 divided by 2. So 6 divided by 2 plus 19 divided by 2 makes 25 divided by 2. And so that's the answer to part A. Yeah? Okay, cool. So let's move on to the other parts then. So part B is next. Okay, so part B. Part B says this: evaluate the integral from 1 to 6 of g of x dx. So find the area bounded by the function g of x, so this graph, and then the vertical lines x equals 1 and x equals 6, and then the x-axis, right? Okay, so we've kind of done this already. So from x equals 1, so let's draw our vertical line. So this is a bound, and then x equals 6 is a bound, okay? But otherwise, the integral clearly just represents the area here plus the area there, right? Now, I'm going to separate the two areas in this way, and one of them I'm going to still have in blue, and that'll just be the area determined by the horizontal line right here, right? And that horizontal line is just a function, the function g of x equals 2 on this portion anyway, right? From 1 to 3. Okay, and then from there on, the quadratic takes over. And so the area bounded by the quadratic and the x-axis, I'm going to color in red. So we see that this integral right here is equal to the blue area plus the red area, right? Okay, cool. So that is, we're going to write that this equals, and I guess I can write our solution in red, that the integral from 1 to 6 of g of x dx equals the area from 1 to 3 of the constant function, and that is g is a constant function from 1 to 3, and it's just that flat line right there. And so that's g of x equals 2, as I said. So this is 2 dx. And from there, the quadratic picks up. So from 3 to, and then it's 6. And then the quadratic, we're told, is given by that guy right there. So that'll be 2 times x minus 4 squared dx, right? Okay, cool. Now, this guy here is going to be 2x evaluated at 1 and 3, and then plus the antiderivative of this. You can do more carefully, and if you want, you could actually like expand x minus 4 all squared is x squared minus 8x plus 16, and then multiply that by 2, and then term by term integrate. But you can easily integrate it exactly as it's written, and the integral is going to become 2/3, and then it's x minus 4 cubed, and we want to evaluate this at 3 and 6. So this guy is going to turn into, let's see, 2 times 3, so that's 6 minus 2, and then we'll have plus 2/3, and then it'll be plugging in 6, so 6 minus 4 is going to be 2, cubed is going to be 8, and then minus 2/3, and then times plugging in 3, so that's going to be 3 minus 4, which is -1 cubed, is -1. So this is what we'll have, and this is clearly 4. So we have 4 plus, and then we have 16/3, 4 plus 16/3, and then we have plus 2/3, right? Okay, so that makes 4 plus 16/3 and 2/3 make 18/3, which is 6. So 4 plus 6, or 10. Yeah, okay, cool. So that completes part B, and let's keep it moving to part C. Part C says, what does part C say? And that's part A. Okay, I want to take part A away also, and then let's look at part C. Part C says, for the interval from -5 to 6, on what open intervals, if any, is the graph of f both increasing and concave up? So f increasing means that f prime is greater than 0. And then f concave up means f concave up means f double prime is greater than 0. So we need both this to be true and this to be true. Now let's translate in terms of g. Remember, g is equal to f prime. So we're saying, where is g greater than 0? And then where is g prime, which is the slope of this graph, because that's what g prime will be. G prime is greater than 0, meaning where is the slope of this graph positive, right? First, let's figure out where g itself is positive. Clearly negative in this part, 0 in this part. So g is greater than 0 only on this portion, right? And that's for x values greater than 0, right? And with the exception of this guy right there at 4. So g is greater than 0. That is, this is true for x greater than 0, x not equal to 4, right? Okay, cool. And now let's look at where g prime is greater than 0. That is, where is the slope of this graph, g, positive? And there we see that the slope of g is positive in this portion, and then to the right of 4, right? And so we see that those two places where this is true are going to be between 0 and 1, and x is greater than 4, right? So that's it. And by the way, they tell us to end at 6, so I guess instead of x is greater than 4, I could write 4, 6. Now, remember, this is true anywhere to the right of 0 except for x equals 4. And this is true in here and in here, where both are true, therefore, is going to be this and that. So that's the answer. Because on the interval from 0 to 1 and then from 4 to 6, we have that f prime is greater than 0, meaning f is increasing, and f double prime is greater than 0, meaning that f is concave up. Yeah? Okay, cool. So that's the answer to part C. And then finalement, part D, right? Okay, so let's go to part D, and we'll be done with this problem. Part D, right there. It says, find the x-coordinate of each point of inflection of the graph of f. Give a reason for your answer. So we're looking for points of inflection. And we know that they happen where f double prime is equal to 0, or f double prime is equal to undefined. Or let's just say f double prime undefined. Doesn't make sense to say equal to. Okay, cool. All right. So we know we get inflection points where f double prime is 0 or f double prime is undefined. But this and this are not sufficient, right? Whatever x values where this is true and this may be true, we also need f double prime to go from positive to negative about those points, or from negative to positive. In other words, we need it to change sign. Now, where it's undefined are a bunch of places. Remember, f double prime means g prime. So we're looking for g prime equals 0 or g prime undefined, right? And g prime is undefined in a lot of places, like right there. That's x equals -2 right there, right there, right there. These are all sharp turning points or cusps on the graph of g. Therefore, g prime is undefined at all of these x values. However, at none of them does g prime and therefore f double prime go from positive to negative. It doesn't change sign about any of them. So we could just ignore all these places where f double prime is undefined or where g prime is undefined. So we could just focus on where f double prime is equal to 0, that is where g prime is equal to 0. And that's only at one spot, and that's at x equals 4 right there. So the result for this is x is equal to 4, and clearly g prime, which is the slope of g, goes from negative to positive, so it changes sign about this value of x equals 4. Therefore, x equals 4 is our only point of inflection. Now, a lot of what I said verbally, you might need to write down some of these details on your actual exam to get all the points, but that's that. And this completes my solution to problem 3, and keep watching. Yeah? All right, cool. Take care.